Alright, so we're going to look at the the possibilities worksheet, some more practice problems with the mole concept. But before we do that, just wanted to go over these super special bonus thought things. That first question there, actually the first two questions. Which do you have more of if you have 1 dozen apples or 1 dozen bowling balls? So in your head, you say, oh, a dozen is 12 things, so it doesn't matter, apples or bowling balls, they are the same, and you are correct. Same thing with the mole concept, the chemist dozen. Which do you have more of? 1 mole of hydrogen or 1 mole of lead? It does not matter which is which. They are the same. Okay, so both of these mean that you've got the same amount when you have a mole or a dozen. I'm showing you my awesome pen skills with my mouse. So yes, you have the same amount. 6.02 times 10 to the 23rd particles are in 1 mole. Now, which weighs more, a dozen apples or a dozen bowling balls? Well, hopefully you remember that a bowling ball is bigger than and weighs more than an apple. So 1 dozen bowling balls would indeed, in fact, weigh more. So which weighs more, 1 mole of hydrogen or 1 mole of lead? Well, hydrogen is the lightest element on the planet in the universe. Lead, each atom of lead is much heavier. So when you put 6.02 times 10 to the 23rd lead atoms together, they're going to weigh more than 6.02 times 10 to the 23rd hydrogen atoms. So the 1 mole of lead weighs more. So when we're looking at this worksheet then, on a lab bench there's 3 containers. The first one has 1 mole of aluminum, the second one has 1 mole of copper, and the third contains 1 mole of platinum. So which container contains the most atoms? They all have the same amount of atoms. They all have 6.02 times 10 to the 23rd atoms in them. Which container weighs the most? That's going to be platinum, since its molar mass is the greatest, 195.1 grams per mole. Aluminum's 27, copper is 63.5. So again, if you have the same number of moles, you have the same amount of particles. The weight will be different depending on what elements are in that sample. All right, question 2. The field crew at Progressive Field uses ammonium nitrate, the fertilizer, and this year they used 12,750 moles of fertilizer. How many molecules is that? So to go from Moleville to Particle Town, from moles to particles, you have to multiply by the chemist's dozen, Avogadro's number, and that's how we get 7.6755 times 10 to the 27th molecules of fertilizer. Question 3. In that neon sign in the Cardinal Cafe, the red portion was made with 450 grams of neon. The blue circle was made with 2,500 grams of xenon. So which sign contains the most atoms? Well, you can see there's a significantly larger amount of xenon gas in grams. But does that translate to atoms? Well, here's what you got to look at. For neon, you take the 450 divided by its molar mass, 20.2. For xenon, you take the 2500 divided by its molar mass, 131.3. So even though the mass amount is larger for xenon, each xenon atom is much bigger than a neon atom. So realistically, there's 22.3 moles of neon in the tubes, 19 moles of xenon. Less moles means less particles. If you have 5 dozen cookies, you have less cookies than if you have 10 dozen cookies. If you actually wanted to calculate it out, that's fine too. 22.3 moles means you would have 1.34 times 10 to the 25th atoms, whereas for the xenon, that would calculate out to 1.15 times 10 to the 25th atoms. So you could see that is, in fact, less atoms. Question 4. Tying in the concept of density and the mole, here you have a scrapyard collecting iron. Well, density is mass divided by volume, so mass is the density times volume. So when I do that, I figure out that there's 3,030 grams of iron. That puts me in Mass City. Now I can change that to moles and then change that to atoms. So I take my mass of iron divided by its molar mass, and then I would multiply that by Avogadro's number to figure out that there's 3.27 times 10 to the 25th atoms. Our last question, if we've got a gas cylinder containing 484 grams of dinitrogen pentoxide, how many oxygen atoms are in that cylinder being shipped? So the first thing I would do is, I'm in Mass City, 484 grams, so I divide by the molar mass, 108 from the periodic table, 2 nitrogens, 14 plus 14, 5 oxygens, 16 each. That makes 90. That's how we got the 108. Sorry, 16 times 5 is 80. That's how we got the 108. So when I divide, I figure out there's 4.48 moles of the dinitrogen pentoxide being shipped. I multiply that by Avogadro's number, I get 2.70 times 10 to the 24th molecules. However, N2O5 means that there are 5 oxygen atoms in every one of those molecules. It's like eggs in a carton. If I have 1 carton of eggs, there are eggs inside the carton. So I have more eggs inside than I do the carton. Typically there's a dozen, so there's 12 eggs per carton. This formula means 5 oxygen atoms per molecule. So I have to take that molecule answer, multiply it by 5, and I see that there are 1.35 times 10 to the 25th oxygen atoms that are being shipped. Alright, hope that helps.